All right, so in this video, we're going to go over some momentum concepts from the 312T lesson. Let's get into it. Here we go. So we've got a 1.4 kilogram bullet. It's been fired from a gun and it hits a stationary block. So this maybe you're at the firing range, you're testing out that new gun you got for Christmas, and you were sighting it in or whatever, we're just doing the momentum. Hey, how far does that ballistics gel block move when that little tiny bullet hits it going really fast? That's what we want to look at. So how do we handle a problem like this? So the challenge with a problem like this is forces are too complex in this situation. We have air resistance we have to take into account. We have the drag, like we have the rotation of the bullet. It's flying funny. It's way too complex. So what we can actually do is use momentum to help us understand this problem a little better. So we're going to use this concept called conservation of momentum, where what we say is the initial velocity, p sub 0, is equal to the final momentum. Okay, and so here we have two sets of momentum. In the initial section here, we'll do this in red, we have the momentum of the bullet, so we'll say momentum of bullet, and plus the momentum of the block. And then that's going to equal our final momentum here, which is the momentum of the final momentum of the block and the bullet, because the bullet here is going to lodge inside the block. So it's not like it's going to pass through it. It's going to get stuck inside the block, and it's going to be stuck there. It can't move. So these are our momentums. Now, one nice thing, we know that the block is stationary. So that means its velocity here is equal to 0. And so if we recall, momentum by itself is equal mass times velocity. Well, if the velocity is 0 here, that means the momentum of the block is 0. So the momentum of the block is 0. So we don't even have to worry about that term, which is really nice. So all we have to do is worry about the momentum of the bullet. So if we're thinking about the initial side, we're just going to do the mass of the bullet multiplied by the velocity of the bullet. And then that's going to be equal to our final situation here. And so our final here, since we have the block and the bullet, they're going to have a combined velocity. And we'll do this in blue here. But we're going to have to do the mass of the bullet plus the mass of the block. Okay. And so that's what our equation is going to look like there. So this is an inelastic collision. So here the two things are stuck together at the end. So they're going to have the same velocity with a combined mass. Okay, so there is our equation. Turns out that we know the velocity of the bullet, we know the mass of the bullet, we know the mass of the bullet, and we know the mass of the block. We are looking for the final velocity here. So we're going to do a little algebra here. We'll do that right over there. And our algebra is going to end up with mass of our bullet. We'll just do 1b there times the velocity of our bullet divided by the mass of the bullet plus the mass of the block. And we'll just leave, for the sake of subscripts here, the regular m here is going to be mass of the block. And that's going to give us our volume. So now all we have to do is plug and chug, and we're going to get our values. So let's go ahead and put those into the formula, and then we'll type them into our calculator here. So if we punch those in, we're going to have 1.4 grams. We can't use that. We have to put that into kilograms. So that's going to be 0.0014. There's a decimal right there. Kilograms. So we have to make that conversion. So we have 0.0014 multiplied by our 417. Wow, that thing is cooking. Meters per second. And then we're dividing that by 0.014. I'm missing a 0 there. There we go. 0.014 plus the 1.1 kilograms. And so we're going to punch that into our calculators and get a value. So I'm going to pause the video here. Go ahead and punch that in. See if you get the value I'm going to get. I'm going to be back in 3, 2, 1. Bam! And there we have it. We have 0.530 kilogram meters per second. Booyah. Let's do this. Moving on. Okay, so let's do another problem. Okay, so here we have a cannon. We're playing some old school warship game. Maybe we're playing Pirates of the Caribbean, or what's that new one? Sea of Thieves. There you go. Playing a game. We're shooting a cannon from our ship here. We got a 2 kilogram cannonball. It's fired from a 118 kilogram cannon at a speed of 131 meters per second. What's the recoil speed of the cannon? So again, we're using momentum here. Okay. Forces are too complex. We'd have to look at our reactionary forces. There'd be impulse. It'd be nasty. So we do our initial has got to equal our final. Now, if we think about our initial situation here, the cannonball and the cannon are together. So we're going to have our combined masses here. So we're going to have the mass of the Cannonball with B, and then the mass sub C is going to be our cannon. So we have the combined mass, and then we're going to have that velocity. Okay, so that's going to be our starting one. Again, momentum is mass times velocity. This is an inelastic situation to start. Inelastic meaning they're together. So the masses are combined, and we have one velocity. Now, the final situation, the cannonball departs from the cannon. So now we have two entities. And so the cannon's going to have a momentum. The cannonball is going to have a momentum. Okay, and so we have to split that here. So for our final situation, we're going to have the mass of the cannonball plus the velocity of the cannonball plus, oh, I'm sorry, not I miswrote there. It's not going to be plus here. How about multiplication between those two? So we have the mass of the cannonball multiplied by the velocity of the cannonball, and then we're going to be adding the mass of the cannon times the velocity of the cannon. Okay, so we want to know the recoil speed of the cannon, the recoil speed of the cannon. So that means we really want to figure out, hey, what's this value right here? So let's do a quick check. Do we have everything else? All right, so we have the mass of the cannon, we have the mass of the cannonball. So all these masses are taken care of. We have all those values. Okay, we have the speed of the let's see here. It's fired from a cannon with a speed. So this is the speed of the cannonball. So we know this speed right here. And then we have to ask ourselves, hey, what is this speed right here? It never told us what this speed is right here. Well, let's think about our cannon. When we're firing our cannon from the deck, is that cannon moving? Is the cannonball moving? No, neither of them are moving. So this guy here has to be 0. Oh man, this made this problem way easier. Since our cannon is not moving, this entire side here, this whole thing right here is equal to 0. So we don't even have to worry about any of this. It's just equal to 0. So let's go ahead and reset up our situation. We have 0 is equal to MB VB plus MC VC, and we want to solve for this guy right here. We just got to do a little algebra, a little arithmetic, get him by himself. I'm going to go ahead and subtract MB VB to the other side. Okay, rewriting over here on the side, we've got negative MB VB is equal to MC VC. I'm going to divide by MC on both sides. Those cancel, and so my velocity here, velocity of my cannon, is going to be negative MBVB all over MC. So now we just need to punch in our numbers and go. We punch in our numbers, we're going to get a negative. Mass of the cannonball is 2 kilograms, multiplied by the speed, 131, divided by that mass of 118. There we go. Punch it into your calculators. Here we go. In 3, 2, 1. Boom, there it is. Negative 2.2 kilogram meters per second. Now hold the phone. Why is it negative? Negative velocity, what's going on here? It's negative because it's a recoil speed. It's in the opposite direction of the speed of the cannonball. And that makes sense. When you fire a gun, generally what happens is that gun recoils back into your body. And what that is that's a conservation of momentum situation here. When we accelerate something really hard out of a firearm, that is going to cause recoil back on your body, and that's what happens there. So it oftentimes, on like an old sea ship, that cannon would like fling back. They'd actually have to have ropes to hold the cannon from going off all the way across the deck, because it would get that moving. That thing would have a lot of momentum and you can just carry. So there you go. 2 examples of how you use conservation of momentum in elastic and inelastic situations. It all comes down to understanding, where's my mass? Is it combined? Is it separate? What's the starting velocity? What's the final velocity? What am I looking for? And then doing some arithmetic. Hope this video helps. We'll see you on the flip side.